Lesson 31, Curves and Regions, Example 6. The curve on the Argand diagram for which the modulus of z plus 3 plus the modulus of z minus 3 equals 10 is an ellipse. Write down the coordinates of the centre and the lengths of the major and the minor axis of the ellipse. Now, there's two ways of doing this, algebraically and geometrically. I'll start with the algebraic method first, which is rather long and, I must admit, rather tedious. So let's have a look at this. First of all, we'll have a look at this modulus here. Okay, and we'll have, this becomes square root of x plus 3 all squared plus y squared plus the square root of x minus 3 all squared plus y squared is equal to 10. Right, now I'll take this across the other side. I'll have the square root of x plus 3 all squared plus y squared equals 10 minus square root of x minus 3 all squared plus y squared. Now squaring both sides, get x plus 3 all squared plus y squared equals 100 minus twice the product, 20 root x minus 3 all squared plus y squared plus x minus 3 all squared plus y squared. Moving the brackets, we get x squared plus 6x plus 9 plus y squared equals 100 minus 20 root x minus 3 all squared plus y squared plus x squared minus 6x plus 9 plus y squared. Right, now this will cancel out with this. The 9's go. The y squareds go. We'll take that minus 6x across the other side. We get 12x and the 100 minus 100 equals minus 20 side of the square root of x minus 3 all squared plus y squared. Alright, now we'll divide through both sides by 4 and we get 3x minus 25 is equal to minus 5 outside the square root of x minus 3 all squared plus y squared. Right, we'll square both sides again and we get 3x minus 25 all squared equals 25 outside of x minus 3 all squared plus y squared. Now this becomes 9x squared minus 150x plus whatever 25 squared is equals 25 outside of x squared minus 6x plus 9 plus y squared. So this equals 25x squared minus 150x plus 9 times 25 plus 25y squared. So now this becomes, now we'll take this across and we'll have minus 16x squared. These go out. That's nice, isn't it? Minus 25y squared. Should have gone the other way, it doesn't matter. And then you've got 9 times 25 minus 25 times 25. Just checking those signs there. That's a minus. That's right, isn't it? And a minus. Yep. Okay. So we'll write that as 16x squared plus 25y squared is equal to, and that will be 25 outside of 25 minus 9. So we get 16x squared plus 25y squared equals 25 times 16. Now divide both sides by 25 times 16. Oh, running out of space here. I'm going to get, this will be 25 times 16, 25 times 16, 25 times 16. So now you have x squared on 25 plus y squared on 16 is equal to 1. Right, so now we go back to the top. Little diagram was the major axis that we must have been here at 5 and minus 5. This would have been 4 and minus 4 for your ellipse. And the set, of course, is the origin. Now, I think you can see in this the second method, the geometrical method, is far superior to the algebraic approach. But you've got to know a little bit about conics. And what it's saying here is that distance from minus 3 plus the distance from 3 is equal to 10. So it's constantly equal to 10. This is the property of the ellipse. And these points here, the 3 and the minus 3, are in fact the foci of the ellipse. It's minus 3. So you've got to know this. And what we're saying is, as the ellipse moves around, this point moves around, right, then this is a constant. And the formula for that is that we call that S dash. And S, P S dash plus PS is equal to 2A. Now, if you've been studying conics, this is pretty standard. So we know that 2A is equal to 10, where A is the semi-major axis, or 2A is the major, and A is equal to 5. So we know that this distance here, we've got straight away, we've got the major, and that's going to be equal to 5 this side, and 5 that side, so it's minus 5, 5. It's an S there, not a 5. Right. Now to get the minor axis length, we have to know that at the focus, that's the point AE, and that gives you the eccentricity of the ellipse. Okay, and we know that's equal to 3. And we know A is 5, so the eccentricity is 3 on 5. Then using this formula, B squared on A squared equals 1 minus E squared, you see that B squared equals A squared, which is 25, into 1 minus 9 on 25, and that becomes 25 times 16 on 25. So B squared equals 16, which means B is equal to 4. And there you have it. And that must be 4. And that must be 5 minus 4. So the length of the major axis was 10. So the major was 10, and the minor was 8. It's a lot faster, isn't it?